Hello, Health Science 3052 students. This is Professor Van Dyke with your week 5 video. I wanted to make sure that you have this material in video and also in PowerPoint because this will be on the midterm, the first midterm. So I want to make sure you get a chance to hear the video along with the PowerPoints. So we're going to jump right into it with slide 1. With environmental disease, there are a lot of definitions that I want you to be familiar with. So a disease is essentially going to be anything that is a deviation from the normal. So anytime that you have any deviation from the normal, whether it's acute or chronic, these are things that we tend to classify as a disease. So we have infectious diseases and we have non-infectious diseases. So with infectious diseases, essentially you're dealing with a pathogenic organism. We really saw this with coronavirus, of course. This infectious disease that was passed from individual to individual, and certainly deviation from the normal. And then we have non-infectious diseases, which are not pathogenic and not transmitted from person to person. And these tend to be the things that we're focusing on more today with public health in regard to things like cancer and heart disease and diabetes, that these things are non-infectious. When we have endemic diseases, these are things that are going to occur in low levels and tend not to spread very far. There's always an option in regard to public health response to try to control things before they become epidemics. Endemic is going to occur in small numbers, in low level, and very geographically isolated. You can see like endemic outbreaks on islands and things like that. And then we also have epidemics, which are affecting large numbers of people. An epidemic can be something that can affect a whole country or globally, like with coronavirus. We have acute and chronic. Acute is going to be a short-term single exposure. It tends to be something that you deal with and very rapidly fight it off. And then we have chronic conditions, which are long-term, can be multiple doses. And with a chronic condition, this is something that you usually end up dealing with for many, many years. We also have pandemics, which are kind of what we're in with coronavirus right now, where this is something that is going to be a worldwide epidemic. It's a disease that is spreading throughout the world, and we would consider this to be a pandemic. On to slide 2. We're going to talk about mutations here, and mutation is going to be any change to the genetic material. When it occurs in the egg or in the sperm, it can be very, very serious and have bad effects on the individual for their entire life. Everybody's familiar with the concept of a gene, which is a selection of chromosome consisting of about 1,500 base pairs, and they're going to be responsible for production of proteins and cell function, and are very critical for the life of an individual, obviously. So we're dealing with DNA molecules that have to be kept intact, and when there are changes to this genetic material, we would consider these genetic mutations, and these can be problematic for individuals. On to slide 3. When we talk about chromosomes, these are composed of DNA molecules, and obviously everybody's familiar with adenine, cytosine, thymine, and guanine, and these are going to be a twisted helical configuration. So as you remember, adenine and thymine and guanine and cytosine will bond together, and this will compose the chromosome. We have 23 pairs for a total of 46 chromosomes. And when there are changes to that number, that can be problematic. And we will talk about some of those changes here shortly. Slide 4 is a graphic of DNA, the double helix. I'm pretty sure everybody's seen this, but you can see adenine and thymine and cytosine and guanine bonded together there. On to slide 5. This is just another graphic that shows the pairings, and of course you see with the 23rd pair, that is the X and Y. These are going to be the sex chromosomes. On to slide 6. So we have a couple mutation types, and when we talk about point mutations, these are gene mutations that are very common. So this occurs where there's a deletion or addition of a base pair, resulting in misreading of the genetic code, a change that essentially can be very problematic in that it can generate things like sickle cell anemia, hemophilia, and diabetes. So again, now keep this in mind. These are point mutations, and I'm pretty sure there's a question on your first midterm in regard to point mutations. And just so you remember that a point mutation is something that is just a single point that is changed on the genetic material, and it can cause things like sickle cell anemia, hemophilia, and diabetes. These are small, very small changes, very small mutations. Just addition or deletion of a single base pair. So that's what we would consider a point mutation. On to slide 7, we also have chromosomal aberrations. Now these are gross structural changes in the chromosome caused by addition or loss of a portion of a chromosome or reversing. There could be a number of things that can occur that can potentially have lethal effects. And now keep in mind, this is not a point mutation. A point mutation is things like sickle cell, where there's only one base pair taken or added. A chromosomal aberration is going to be an extraordinary change in the structure of the chromosome that's going to have usually lethal effects, but sometimes not so much so, and we'll talk a little bit about some of these. So mutations continued, change on, this is slide 8, a change in chromosomal number can also be a mutation. This is caused by a failure of a separation of a paired homologous chromosome, and this usually occurs during meiosis, cell division. So this can generate things like Down syndrome, which is where the individual have 47 chromosomes as opposed to the 46, which is the standard number. Now this is not a point mutation. This is a gross aberration. So some other examples on slide 9. This is Klinefelter syndrome, and this is the change again in the chromosomal number. So with Klinefelter syndrome, you're going to have 47 chromosomes, and you have an extra X chromosome. So this is XXY, and as you remember from the sex chromosomes, you're either going to be XX for female or XY for male. And with Klinefelter syndrome, you have 47 because you have that extra X chromosome. Now, with Klinefelter syndrome, usually these individuals will be, they're going to survive, but they're going to have some unusual characteristics. They're going to have learning disabilities. They'll generally be infertile, and they'll have breast enlargement after puberty, despite the fact that these individuals tend to be male. On to slide 10. This is a graphic of Klinefelter syndrome. Again, with 47 chromosomes XXY, you're going to have a tall stature, slightly feminized physique, breast development, very small testes, and these individuals tend to be sterile, as you remember. On to slide 11. So Turner syndrome, we'll discuss that next. Turner syndrome in females generally, and this is going to be a missing X chromosome. So again, this is a chromosomal aberration. This is not a point mutation like diabetes. Turner syndrome there are going to be some specific characteristics for the individual. They're usually going to have no breast development, very stunted sexual development, and these individuals also have sterility issues as well. On to slide 12. You'll see the graphic for Turner syndrome here. There's going to be a low hairline, a shielded shaped thorax with the heart. So these individuals tend to have a very challenging life in regard to anatomy and both physiology as well. On to slide 13. So we're going to talk about some of the causes of mutation here. What's going to cause these things to occur? And certainly exposure to cosmic radiation can cause mutations to genetic material. This can cause a spontaneous mutation within individuals. X-rays can cause mutations, which is one of the reasons that you get so few X-rays throughout your life, hopefully. This certainly has been one of the reasons that airlines, the airports have worked so hard to develop a better X-ray system. You can be exposed to mutagenic chemicals. So again, mutagenic, referring to things that can cause mutations, things like formaldehyde, mustard gas, nitrous oxide, vinyl chloride, and other mutagenic substances. So there are a lot of chemicals out there that can cause mutations, not just cosmic radiation or X-rays, but exposure to chemicals as well. And these can mutate the genetic material. This can mutate your DNA and can cause very negative effects associated with that. On to slide 14. Slide 14. Birth defects can be caused by mutations, and because we call these teratogens. So mutations, mutagens cause mutations, teratogens cause birth defects. Carcinogens cause cancer. So I want you to be familiar with those terms. Teratogens are something that can cause birth defects. These are mutations of the parental sex cells, and these can cause structural and functional abnormalities in children. Not all birth defects are due to mutations, but certainly it accounts for at least 25% of all birth defects. So again, teratogens are substances that are known to cause birth defects, and we'll talk about a couple of these here coming up. On to slide 15. If you've ever taken Retin-A, you know that one of the first questions they ask you is, are you pregnant? And then they generally will do a pregnancy test anyways before they prescribe specific things. And certainly Retin-A is one of those teratogenic components. It's a teratogenic chemical that can have birth defects. So certainly we can talk about nutrients and minerals that are absorbed into your diet, and phenylalanine is also another, and these can be teratogenic, and these are essentially nutrients that we can get from our diet, but if we're taking things like Retin-A, it's really going to increase the amount of vitamin A in the body. But there are also other things like diseases during pregnancy. So German measles can cause cataracts, heart defects, or deafness, and of course the German measles, which is rubella, that's a part of our inoculation for the MMR, measles, mumps, rubella. So for those of you that don't believe in vaccines, you should study that and give that some thought, especially if you're considering having a child. And then there are also other things that cause birth defects, like medications that we take, like thalidomide, which used to be a mild sedative. It caused phocomelia, which is the seal limb condition. And on slide 16, there's an image of a young girl that had developed phocomelia because her mother was taking thalidomide. Now, it used to be that thalidomide was a very common over-the-counter drug. It was given to women who were pregnant because it helped with morning sickness. And unfortunately, the doctors at the time did not understand that it caused this condition until it was too late. So there were a number of people that were born with this condition, and thalidomide is still used in third world countries in very remote areas at times. But generally, we've seen that thalidomide has been completely banned in most countries. So fortunately, it's no longer around. But the health effects associated with it were certainly very noticeable. And these are one of the reasons that the FDA works so hard to make sure that drugs are very properly screened and that they're tested before they're released into the marketplace. On to slide 17. So when we talk about cancer, we're really talking about a collective term referring to a number of diseases that differ in origin. So they're coming from different places. Prognosis and treatment can be very different. It's a condition where the factors regulating normal cellular function don't function correctly, and these lead to an uncontrolled cell proliferation. So the cells really begin to spread. Potentially they can metastasize, they can grow tumors, And cancer cells, unlike normal cells, will continue to divide and to spread, and they can invade other tissues. So they're very, very dangerous. And again, as I had mentioned before, carcinogens, these are substances that are known to cause cancer. So we have mutagens, which cause mutations. We have teratogens that cause birth defects. And now we're talking about carcinogens, which cause cancer. Very dangerous and very problematic. So some of the causes of cancer, again, like with the teratogenic effects, where we can look at nutrients and we can look at medications and we can look at exposure to x-rays, a lot of causes to cancer too. So as you know, with viruses, certainly everybody's familiar with the human papillomavirus causing cervical cancer, but we also have other viruses as well, like hepatitis B, that can cause liver cancer. But we also have bacteria as well, like Helicobacter pylori, which causes stomach ulcers, and non-Hodgkin's lymphoma. So there are bacteria as well. But then there's also hereditary piece. So if you, obviously you've probably had a number of health screenings, and one of the things they ask you is, did your parents have cancer? Because that can increase your risk of developing cancer as well. So very important that we understand that there's a hereditary piece to this as well. On to slide 19. So this is a list of some teratogens and the effects that they can potentially have. These will not be covered on the exam other than thalidomide potentially causing phocomelia, but you can read these over and take a look at them. On to slide 20. So with slide 20, we're looking at environmental carcinogens. What's in the environment that could potentially cause cancer? So certainly smoking. Nicotine is known to cause lung cancer. Obviously, it doesn't. It's not 100% that if you smoke you're going to get lung cancer, but certainly it has been linked to lung cancer. We also have dietary factors as well. So if you lived on hot dogs every single day, you'd probably be a little bit concerned that you might develop specific dietary carcinogenic effects associated with all the sodium nitrate that you would be eating. So there are dietary factors as well. Some food additives and artificial coloring can be potentially carcinogenic. Caramel coloring has been known to cause cancer in rats, but that has been in extremely high doses. So again, there are dietary factors that can affect individuals. But we also have aflatoxins. These are things that are produced by a bacteria called Aspergillus flavus, and it's growing on cereals, peanuts, and can cause liver cancer. So Aspergillus flavus, which is an aflatoxin, can cause specific forms of liver cancer, which is one of the reasons that the FDA works so very hard to control some of these environmental carcinogens in regard to our exposure. If they find a crop that has Aspergillus flavus on it, the crop is immediately destroyed, and that can increase post-harvest loss in regard to harvest production. On to slide 21. We also have air pollution. So this is considered an environmental carcinogen. Among other things, it can cause certainly COPD and respiratory conditions like asthma and bronchitis. But air pollution can also be considered a carcinogenic effect because it causes things like liver cancer through anesthetic gases that are very commonly used, lymphoma, potentially you have benzene that causes leukemia, and you even have hardwood dust, like if you work in an area where you're constantly cutting wood, hardwood dust, which is an air pollutant, can cause malignant nasal cancer. So lots of stuff going on here in regard to exposure through air pollution that can be carcinogenic as well. So asbestos can of course cause lung cancer through mesothelioma. Vinyl chlorides, which used to be found in flooring materials, could cause liver cancer, things like that. So on to slide 22. Some other factors for cancer, certainly reproductive sexual behavior, high breast cancer, and early onset of menstruation are have been noticed. So increases in breast cancer based on early menstruation processes, and then HPV causing cervical cancer as well, which we had mentioned before. So these would be considered viruses. Essentially, HPV is a virus, but you notice that there's a correlation between high breast cancer rates and early menstruation. So reproductive and sexual behavior can have an effect in regard to specific cancers. So on to slide 23. This was always something that I loved to discuss in class because this was the cancer rate associated with males in the United States from 1930 to 1990. And you'll notice that there was a fairly substantial jump in lung cancer right around the time period of about 1945. And one of the reasons for this was that we really one of the things that as a United States soldier you could always count on was that you would always have plenty of cigarettes, and it definitely increased the number of smokers in the United States right around 1945, from 1940 to 1950, and those individuals came home and continued to smoke. So you can definitely see that by this graph here. Moving on to slide 24, and again you'll notice that female lung cancer took a big jump right about 1962, 1963, and one of the reasons for that was that advertisers for smoking began to realize that they were missing out on a substantial market. So with women's liberation, they really began to push this new attitude towards female smoking. And I'll never forget, Virginia Slims had an ad that was in the 60s, 70s, and essentially said, "You've come a long way, baby," which was shocking and disturbing to us here in modern times on so many levels, that there would be this segregative component that specifically began to target individuals that female individuals that would drive this increase in that subset of the market, that the female market was now being targeted. And you could see that increase in lung cancer if you look at this graph here. Onto slide 25. So how do we prevent cancer? Lots of means that we can have at our disposal. One of the things we can do is we can stop smoking, which is a very helpful component. We can also avoid excess exposure to the sun. Use sunscreen. Do yourself a favor, but do what you can. Do the best you can. And obviously, for many of us, we can't avoid sun exposure here, especially here in California. We love to be outside, but certainly sunscreen is a big help for that. Number 3, we can avoid exposure to carcinogens. Do the best you can. If you're working with chemicals that you know are carcinogenic, make sure that you wear your PPE. Do everything you can to avoid those carcinogenic components. You'll notice that a lot of hot dog companies began removing things like specific sodium and nitrosamines and the components that essentially after cooked could be carcinogenic. So look for those things in your food. We also have number 4, which is avoid exposure to radiation. I don't think any of us specifically go out and try to radiate ourselves or get extra x-rays and things like that, but do the best you can to avoid that radiation. Number 5, eat low-fat, high-fiber foods. Now this is kind of the opposite of what we do in the United States. We tend to eat low-fiber and high-fat foods, and that can be a dietary consideration for potential carcinogenic effects. But again, this is one of those things that is a protective element. So if you eat low-fat, high-fiber foods more frequently, these are the kinds of things that can help you in regard to avoiding cancer risks later in your life. Reduce salt-cured, pickled, smoked, and charred foods, which are kind of all my personal favorites, but we do the best we can and we eat them in moderation. That's number 7. Eat food that's rich in vitamin A, C, and E. These can also assist you very much in regard to preventing cancer as well. And then number 8, reduce obesity. So we do the very best we can to try to make sure that we can maintain a healthy lifestyle, and reducing obesity can be a benefit when it comes to reducing cancer risk. And then reducing psychological stress, minimizing stress. Your body works its best when it's not in a stressed state. So keep that in mind. This is one of the things that can be very beneficial in regard to fighting and preventing cancer from occurring. So this can be very helpful that you're able to reduce and minimize your stress. Now I know that for some of us that can be a challenge. I know that with many of my students, you're working full-time jobs and you're living very busy lives, and I do my best to help you reduce stress with this class. I want to make sure that my students are well prepared and that they are they have all the tools they need for success, and I take great pride in doing my best to ensure that my students are able to minimize that stress and that they have the time to do what they need to do to be successful in school and in life. So with that, I hope you enjoy this PowerPoint. It has a lot of helpful and useful information, and this will be covered on the midterm, so I hope that you all have a chance to view it, and I hope you have a great week. Let me know if you have any questions as we approach the first midterm. Obviously, the study guide is posted, and it gives you a really good idea of what's going to be on the test, so make sure and read that over and be well prepared. As I had mentioned before, with your first midterm is probably going to be posted fairly early in the day on Thursday, and you'll probably have a good portion of the day to do that midterm. But don't take all day to do it, because you'll time out and you'll have all kinds of problems. And just sit down and hammer it out when you're ready. So make sure and do it on Thursday. And with that, have a wonderful day.